All right, guys, so here we go with part 2 of the video, metal ions. So we talked about how non-metals form negative ions. Well, metals will form positive ions. They will lose either 1, 2, 3, or 4 valence electrons, revealing the octet layer underneath. Now, it's a little bit complicated, okay? For most metals, there's no easy rule to determine the charge, all right? And so sometimes a metal will give up 1 or 2 or 3. That has to do with the fact, remember the electron configuration, how if it uh, gets rid of that upper S sublevel of electrons, then there's like some D electrons underneath that are like going to go in and fill it. Like, it's kind of like if someone moves out of their house, like, ooh, that's a great house. I'm going to go move into it, get a bit more space. It kind of messes things up. The point is that there's no easy rule for the charges of most metals. All right. Most metals will form many different charges. And so we have to specify in the name what the charge of that ion is. And we do it very simply. All right. We just give the name of the metal element, then a Roman numeral indicating the charge, and then the word ion. So Au1 plus, we'd call that a gold 1 ion. That is a gold with a 1 plus charge. CO2 plus, that's a cobalt with a +2 charge. We'd call that a cobalt 2 ion. That's it. That's the name. Fe3 plus, that's an iron 3 ion. Okay? SN4 plus, that's a tin 4 ion. By the way, the Roman numeral for 4 is IV. Okay? IV. So again, the reason why you can't just say, "Oh, Mr. Gucci, this compound is made of oxides and iron ions." Well, iron what? All right, iron what? Is it iron 3? It's like, well, yeah, it says iron 3 here. Well, guess what? Iron can also be a 1 plus ion, a 2 plus ion, a 3 or 4 plus ion, and it makes a difference. All right, iron oxide with an iron 3 ion gives us rust, all right, which breaks machines down, all right, like it destroys a bunch of stuff, all right. Whereas iron 4 and iron 2 oxide creates something called magnetite, which is like a really useful industrial compound. Looks like a shiny darkish gray. Like, have you ever seen like those? Like you go to like a museum, like usually like it's a museum gift shop. They have like a little bucket of like polished stones. They'll have these little tiny grayish silver stones that clink together. Those are magnetite. Okay, so point is, these metals are going to form different ions with different charges. And you have to tell me what the charge is using a Roman numeral. Okay, so here's an example. Can I write now on this? Can I write? Can I write? I can't write. So I got to, oh wait, I could write. Can I write? I can write. Okay, so a nickel that loses 3 electrons, well, that would be a nickel with a +3 charge. We would call that a nickel 3, Roman numeral 3, ion. And the symbol is Ni with a 3 plus charge. Okay? An iron that loses 4 electrons, well, that would be an iron 4 ion, or Fe 4 plus. This copper here loses 1 electron. Well, in that case, it would be a copper 1 ion, or Cu plus. Okay? A cobalt that loses 2 electrons is a cobalt 2 ion. It is CO 2 plus. Lastly, a lead that loses 4 electrons, that would be a lead 4 ion, or Pb 4 plus. Now we have to specify lead 4 because there's a lead 2. Just like up here, we had to specify this was an iron 2 ion because there are iron 4 ions. They're not as common. There's mostly iron 2 and iron 3, but you don't need to worry about that right now, okay? Point is, all of these atoms can form many different types of positive ions depending on the situation, either the temperature it was formed at, the pressure, the other elements that it was bonding with. Okay, all these things determine what type of compound you're going to end up with, what kind of ion you're going to end up with. And so in the name, you have to specify how positive it is. I'll make this a bit more clear as Roman numerals. If you put these lines on the top and the bottom, it makes them cooler. Yeah. Okay. Let's try another one. All right. Let's try another one. All right. Now, okay. So, last bit for the notes. Like I said, most metals get Roman numerals because they can form many different charges depending on the situation and what they're bonding with. Okay? But there are some metals that don't get Roman numerals because their charges are always the same. They never vary. All right, and these are, for the most part, the metals on the far, far left of the periodic table. Anything in column 1, this column right here, all right, specifically these metals right here, all right, these are called the alkali metals, and they always form 1 plus ions, okay? They always form 1 plus ions, right? They only have one valence electron to give, so they always form +1 ions. By the way, this includes hydrogen. Even though hydrogen is not a metal, it's not an alkali metal, it still forms a +1 ion. Oh God, I'm gonna sneeze. Can I pause? I couldn't pause. I'm so sorry. All right. So sorry. You had to live through that. Okay. Can't move fast enough. Nope, I dropped my pen. This is great. I'm a professional. I'm a professional. All right. All right. So lithium, sodium, potassium. All right. They would just become lithium ion, sodium ion, potassium ion. Even though they're +1, you wouldn't call it a lithium 1 ion. You wouldn't call it a sodium 1 ion. It's redundant. It's always got a +1 charge. Sodium always has a +1 charge. There's no point in calling it a sodium 1 ion because there's no sodium 2 or sodium 3. That would be like me introducing myself. Hello, my name is Mr. Gucci. I am your human being teacher. And you're like, what'd you say? Like, I am Mr. Gucci, and I am your human teacher for today. It's like you're not wrong, but it's suspicious that you said that. Okay? It's kind of like that, all right? Like, if you said lithium 1 ion, people would be like, you discovered some other ion while I was away? What you getting at? You some alien? You from another dimension where lithium can be a +2 ion? Because it can't be a +2 ion here on Earth in the Milky Way galaxy, son. All right? So these guys don't get Roman numerals. Second column, the alkaline earth metals. These guys right here, they only have 2 valence electrons, and so they will get rid of them, and they will always form 2 plus ions. All right? But because they're always 2 plus ions, again, they also do not get a Roman numeral in their name. You wouldn't say a magnesium 2 ion. It's always going to be 2 plus. It's magnesium. It's just a magnesium ion, a calcium ion, a barium ion, a strontium ion. Okay? And so how are you going to know what charges they are if there's not a handy-dandy, Roman numeral right there in the name to tell you? Well, you just got to pull up a periodic table. I inserted something into your notes to help you out, all right? So you can use that. Don't complain. Previous years, you had to memorize it. I had to memorize it. Day 1 of AP Chemistry in 11th grade, I had to come in with every single known ion memorized, and I had to take a 50-question test on day 1. And if I failed that test, they would just pat you on the head, slowly spin you around, and just shove you gently out of the room because you were not going to make it in that class, all right? You just got to look it up on a picture I gave you. So whoop-de-doo, guys. Aren't you so lucky? The answer is yes, you are. I love you too. All right. Onward. All right. There are a couple other metals, a few other metals that only form one type of ion, so they do not get charges, Roman numerals. Aluminum is always the 3 plus. Always 3 plus. All right. There's no aluminum 2. There's no aluminum 1. There's no aluminum 4. And so there's no need to write aluminum 3 because it's always 3 plus. Hello. This is Newt, my cute cat. That's redundant because he's a kitty. Of course he's cute. I don't need to say it, and you don't need to say aluminum 3 ion. You don't need to say a zinc 2 ion because it's always 2 plus. And you don't need to say a silver 1 ion because silver is always 1 plus. That's just it, okay? There's a couple other ones in there like cadmium, all right? Cadmium as well, all right? Tends to only form 2 plus ions. That's like 99% of the time. So yeah, you can maybe get another cadmium ion. Like, is that enough though? Like if it happens 1% of the time, do we say that it's just cadmium? These are the big ones over here. All right, these are the ones where I'm not going to give you Roman numerals because, again, their charges never change. All right, cool. All right, how are you going to know this? You look it up. Look it up in the notes. It's on you. I don't care how you know it. Look it up. All right. So other weird things, hydrogen. Hydrogen is just weird. That's going to be a theme in this class. Hydrogen is just a weirdo, okay? A hydrogen ion is an H+. It gives up one electron. But if we call it hydride, remember that IDE ending is for negative ions? Well, hydride is a hydrogen that stole an electron, and so it's an H-. So hydrogen could be either. It's weird. It's weird. It's in the metal column, but it's an explosive gas. I don't know. Get it under high enough pressure, it turns into a liquid metal. I don't know. Hydrogen's weird. It's just a proton with an electron. Hydrogen's weird. So if it's a hydrogen ion, it's +1. If it's hydride, it's -1. Okay? Notice again, no Roman numeral, no need. If it's a hydrogen ion, that's enough for me to know it's +1. It's not going to be +2. That's impossible. All right? So let's try this out. Calcium. Okay, so first of all, potassium. All right? Potassium as an ion is just called potassium ion, and its symbol is K with a plus or a 1+. All right? Because it's in this column, it's always 1+. You don't need to call it potassium 1. Calcium is a calcium ion. Again, calcium is right here. It's in this column, so it's 2+. But I don't need to call it calcium 2 because it's always that. All right? Again, it's redundant. Okay? This is my beautiful wife. That's redundant. Of course she's beautiful. She's my wife. Okay? Aluminum. All right? Aluminum is just aluminum ion. Okay? Al 3+. Okay, how do I know? Because I had a picture right here that showed me. How did I really know? Because I've memorized it, because I've been doing this for like the better part of a decade. Okay, how are you going to know? Find a picture in your notes. All right, a lithium ion. Lithium forms a lithium ion, which is, oh, here it is. All right, so Li+. All right, which is the same as 1+. Magnesium is a magnesium ion. All right. Magnesium ion, and here it is. It's in that 2+ column, so magnesium always forms a 2+ ion. Lastly, a positive hydrogen ion. Well, here it is, right at the very top of the +1. All right, so we would call this a hydrogen ion. If it was a negative, it would be hydride, and it's H+, which is the same as H1+. I just like the plus there. It looks a little neater. Okay, guys. That's your notes. I'm going to make a little homework help video to help you for the homework, all right? But pretty much it's just more of this thing that I just did here, all right? Good luck. Oh, I'm still playing. How do I stop it again? Uh,